Happy Super Bowl Sunday, folks. Hope you're enjoying your day. Looks like we might get to go to school tomorrow, so the weather's not going to be as bad as they thought. So we'll see what happens. Here's a video on section 2, and we're going to do an activity tomorrow if I get to see you based upon this, so please watch it if you can. How do we classify the different climates in the world? So there's a guy named Köppen. He was a German guy, I think in the 40s, that came up with a system. He first wanted to use just the type of plants or vegetation, but then he realized he needed some numerical values, some numbers to help make this system better. So he threw in the two most common types of weather numbers, which we already know is precipitation and temperature, and he used the average monthly values to add to his system. So the Köppen classification system. So he broke all the world's climates down into categories, and you'll see them in bold print. So the tropical climates, I think you know what tropical means, especially since we talked about air masses and we use the word tropical to identify warm or hot. They have constantly high temperatures, and they sometimes receive a ton of rainfall. You can see the numbers there in bullet number 2. That combination of high heat and rain produces the most spectacular forests, like the tropical rainforests, flowering plants, the most wonderful vegetation in the world. There is no other place in the world that has a more varied plant life than the tropical areas. They also have transition zones. Transition zones are zones leading into other zones that can be really, really dry but still hot, and those are places like the savanna. That's what you would see in Africa, for example, where you see the giraffes and the wildebeest and all those other animals wandering those grassy plains areas. Those are called savannas. The second kind of classification of climate zones are called dry zones. They happen to be the largest type of climates in the world. These are usually the deserts, like the Sahara, the Gobi, and the Australian desert. They are dominated by continental tropical air masses, warm, dry air masses. Very low precipitation, so therefore not much vegetation exists. Only those plants that can really adapt to those environments will live there. The evaporation rates are greater than the precipitation rates. Mild climates. There's 3 kinds of mild climates: humid subtropical, marine west coast climates, and Mediterranean climates. So the humid subtropical is like the southeastern United States. So think about Georgia, Mississippi, South Carolina in the summertime. Muggy, sticky, humid, warm, hot, but somewhat cool in the winter. Not cold. We know that places like Georgia doesn't get real cold weather, but it's cool in the wintertime. The second type of mild climate is the marine west coast climate. Once you think about central California, there's a constant inflow of air off the ocean, because remember, our weather moves from west to east. They have very mild winters and they have cool summers. So basically the temperature, maximum temperature, never gets real hot. You can see people wearing jackets in the middle of summer in San Francisco. There's a great amount of precipitation throughout the year. It doesn't matter what season it is. And as I said, San Francisco is a great example of that. The third type of mild climate is the Mediterranean climate, influenced by the Mediterranean Sea. Even though it's a large body of water, it is incredibly smaller than, say, the Atlantic, Pacific, or the Indian Ocean. Certain areas of Italy and Spain you'll find locations like this. The summers are warm because there's usually no cool ocean, that should be currents, in the Mediterranean Sea. Because the ocean is so small and it's located close to the equator, there's not really any cool ocean currents like there would be in bigger oceans. Continental climates. This is basically any climate that's pretty much inland, not associated with oceans. There's 3 types: warm summer climates, cool summer climates, and subarctic climates. So continental climates are places where tropical and polar air masses sometimes come together. So that's like, say, over Ohio, which is what's getting ready. Ohio and Michigan's getting ready to get the biggest part of this winter storm, the winter storm that we thought we might get. they're getting ready to get a very large chunk of moisture from a tropical air mass, and a very cold air mass is going to come together and form lots and lots of snow. The winter and summer weather can both be extreme, as we're getting ready to see. You can have close to 100-degree temperatures in the summer, and you can have well below zero temperatures in the winter. Okay? And that leads us to polar climates. You can kind of guess what's going to happen here. This is kind of opposite of tropical climates. They're located in the north of continental climates, at least in the northern hemisphere. The average temperature of the warmest month is less than 10 degrees Celsius, so it doesn't get very warm. Generally, the precipitation is low because, remember, cold air does not hold as much moisture as warm air, and you need moisture for precipitation. There's not much convection taking place, so you have to have that lift in temperatures. That lift in the air to get the precipitation, and since there's not that much warm air, you don't get that lift. You can find a variation of a polar climate at higher elevations in warmer areas, such as the Andes in South America. Even though it's closer to the equator, you get way up in elevation, it kind of mimics a polar climate. And you can even see hints of this in the tops of the Smoky Mountains in Tennessee, North Carolina. You can go up to Clingman's Dome in April, 6,000 feet above sea level, and it can be still winter instead of spring, like it is down in Gatlinburg or Pigeon Forge. Microclimates. These are areas that are different from the main climate around them. They're very small areas that have different readings, different precipitation or temperature readings. Sometimes the climate of a small area can be different than the larger area surrounding it. That's kind of a good description of it. So if you find an area that is typically warmer than the area around it, or typically colder than the area around it, would be examples. And it kind of goes along with this is something called a heat island. These urban areas, urban means city, which is surrounded by concrete buildings and streets and asphalt. They tend to absorb a lot of heat when the sun is out, and they radiate a lot of heat back into the atmosphere at night. They radiate more heat than, say, the ground does, like grassy areas and the forest areas and even large bodies of water. So this can make, because of this convection and this heat rising, precip levels can be higher, as much as 15% in large cities, and temperatures can be higher in the daytime and cooler in the nighttime, actually. So these heat islands are examples of microclimates. So that's it. Please take some good notes and please study them, and I'll see you tomorrow in class. That's all. Goodbye.